Let us do one more numerical problem. This problem from Concept of Physics by HCVerma, problem Newton's laws of motion, problem number 24. Let me read out the statement from the book, then I will go to solve it and I will tell you the shortcuts also. This figure shows a uniform rod. Look, this is a uniform rod kept on a smooth surface, and the length of the rod is 10 plus 20, 30 centimeter, and the total mass of this rod is 3 kg. And the mass is distributed uniformly. It is a uniform rod. What do you mean by a uniform rod? I will explain with this diagram. Here is a pulley, a string, massless string, light string, passes over the pulley and is connected to the rod here. This is another string which is passing over the pulley, and from this side a constant force 32 Newton is applied, and from this side 20 Newton force is applied. Now what you have to find is this part, this 20 centimeter part of the rod, what force it is applying on this 10 centimeter part, that is to be found out. So very simple. So before that, let me explain you what you mean by a uniform rod. Since the rod is uniform, means the distribution of mass is uniform. I have redrawn it here. The same rod is here. Suppose at this place I consider from here to here is x centimeter. So, and from here to here is also x centimeter. Now, same length. So, the mass of this part will be mass of this part. Means uniform mass distribution. Means instead of, if this mass is m, if this shaded portion has a mass m, then this shaded portion will also have the same mass because the length is same. If you consider 2x length here, from here to here 2x, then this mass will be 2 times this, that is, this will be 2m. So that is what it is meant by uniform rod. So what do I do is, to make the problem simpler, I have split these two parts, 10 centimeter part here and 20 centimeter part here. This is 10 centimeter and this is 20 centimeter. The total mass of the rod is 3 kg. So in length 30 centimeter, in 30 centimeter, 3 kg mass is distributed. So in 10 centimeter, mass distribution will be, how do I come from here to here? By dividing this by 3. So I divide this by 3, I get 1 kg. So mass of this is 10 centimeter, which I have shown it here, will be 1 kg. Similarly, the 20 centimeter part, this part will contain 2 kg. Now, 2 kg. Now this 32 Newton I am showing it here, and this 20 Newton I am showing it here. I have added a string in between. Whatever force this 20 centimeter part is exerting on the 10 centimeter part is same thing as saying the tension in this string, right? I have this string which I have added to the system. This does not have a mass, so it doesn't make any difference. So the net force on this system, 32 Newton to this side, 20 Newton to this side. So the net force is 32 minus 20, that is equal to 12 Newton to this side. And the total mass is equal to 3 kg. So your net force is equal to 12 Newton to this side, and your net mass is equal to 2 plus 1, that is equal to 3 kg. So your acceleration will be, considering this as the system, this is an internal force which I don't require to find the acceleration, but I am required to find this t. So your acceleration will be net force over net mass, that is equal to 4 meter per second square to this side. Now to find this tension, now just look at this 2 kg, don't look at it here. If you look at this 2 kg, on this side there is 32 Newton, which is pulling this 2 kg to the right hand side, and that is being opposed by this tension. And since this 2 kg is moving towards right, so 32 Newton has to be more than this. So the net force on 2 kg is 32 minus T is the net force on this. So that force will be its mass times acceleration, and acceleration I just found it as 4. So 2 into 4, that is equal to 8. We are interested to find T. So T is equal to, T comes to this side becomes positive, 8 comes to this side. So 32 minus 8, that is equal to 24 Newton. So this part, this 20 centimeter part of this uniform rod having length 30 centimeter and total 3 kg is applying this much force, 24 Newton force on this part. You can do so from here also. If you look at this, this is being pulled towards the right due to the tension T and is being opposed by 20 Newton. So for this 1 kg, the net force to this side is T minus 20 is the net force on this. So that will be its mass, that is 1 times acceleration. Acceleration we have already found it as 4. 4 times 1 is 4. So from this, your T also comes out to be 20 comes to this side. So 24 Newton. Either you find out from here or from here. Doesn't make any difference, one and the same thing. And then let me, supposing this force is not acting, only this force is acting, then what will be the tension here? What will be the tension here? Let me do that in a different numerical problem, and I will tell you the shortcut how to do it faster. Look at here. Suppose this mass is M, this mass is M, this mass is M, this mass is also M. You can take them different. And on the right hand side here you are applying a force F. There is no force to this side. So between these 4 masses, here is a string, massless string. So this F is applied to this mass system. So your acceleration will be net force over total mass, that is 4m. Now, the tension in this part will not be equal. Now let the tension here is T1, let the tension here is T2, and let the tension here is equal to T3. Now let me first derive and then tell you the shortcut. Now let us begin from here instead of here. If you look at this, there is no force on this side, there is no force on this side, there is no force on this side. The only force on this side is to the right, that is the tension T3. For this, the tension is towards this. For this, the same tension T3 is to this side. So, for this, your T3 will be its mass times acceleration. I put it here, F over 4m. Now mm cancels, so 1 over 4 times f. Now, so that is your T3. Now, then come back here. If you look at this m, T2 is to this side, and for this T2 is to this side, and this is moving towards right due to the force F. So for this, the net force is T2 minus T3 is the net force on this. That is equal to its mass times the common acceleration. That is equal to F over 4m. So mm cancels. So that is equal to F over 4. Here we calculated T3. So your T2 is equal to T3 goes to the other side. So this becomes F over 4 plus T3. That is equal to F over plus T3 is equal to 1 over 4. that is equal to f over 4. So 2 times f over 4, that is equal to f over 2. Now, so T3 is calculated, T2 is calculated. Let me rewrite it here. T3 is equal to 1 over 4 times f. T2 is equal to 1 over 2 times the total force. Now, then let us come back here. Now, let us come back here. F to this side, T1 is to this side. Or you can come back here to find T also. Let us come here. Now, T1 to the right and is opposed by T2 minus T2 is the net force on this. So, it will be its mass times the common acceleration, that is equal to F over 4m. mm cancels, that is equal to F over 4. Now, I am interested to find T1. So, T2 goes to the other side, positive, plus F over 4. For T2, I write F over 2 plus F over 4. So, your LCM is equal to 4. So, it is equal to 2 times F plus F. So, 3F over 4. So write it like this, 3 over 4 times the total F. So, your T1 is equal to 3 over 4 times the total F on this side. Now, how to remember this? Now, so without solving all this, you can have different masses also, but the technique will be same. Now, let me explain this to remember it in a different way. How much is this tension T3, which I calculated as this, which I calculated as 1 by 4F. How you have to remember? You have to remember it like this. The mass behind, that is m, over total mass, m plus m plus m plus m, 4m, times the total F, that is equal to 1 by 4F. That is same thing as this. Now, similarly, how much is T2? What is the value of this tension? The mass behind it, that is 2m, over total mass 4m times total F, mm cancel, that is equal to 1 over 2F. That is same thing as this. Similarly, how much is this T1? Let me do it here. The mass behind it, m plus m plus m, 3m, over total mass 4m times the total F. So, that comes out to be 3 over F. So, this tension is mass behind, that is m over total mass, m over 4m times total F. This will be equal to the mass behind, 2m over total mass, 4m times total F. This will be the mass behind, m plus m plus m, 3m over 4m times total F. So, that is the way to interpret it and to do it faster, right? So, I hope it is clear to you. It can help you a lot. Thank you.